Hello and welcome to video number 3 in the differential equations section. In this video we will actually get to look at differential equations. The last two videos covered what we need to know as a foundation, and now we're going to define what it is we're working on. A differential equation is one where I have a function and I relate it somehow to one or more of its derivatives. So for example, y prime equals y plus x minus 3. So you'll notice I have a derivative of a y, and I have y itself, and then I have some independent variables. An ordinary differential equation, we'll abbreviate as ODE, is a differential equation that has a single independent variable. A differential equation that has more than a single independent variable is a partial differential equation, and I won't be covering those. We can further delineate ordinary differential equations with the degree and the order. The order is the order of the highest differential. For example, if my largest differential in the equation was d3y dx3. This would be a third order differential. You might also write that as y triple prime. The degree is the degree of the original function, that is the degree of y. So if I had y prime equals y squared plus y double prime, the degree would be 2. The degree is what determines linearity. If the degree is 1, it's a linear function. And if the degree is greater than 1, it is nonlinear. For example, if I have a function y prime equals y minus t, t is my independent variable, I have a first order linear ordinary differential equation. If I have y prime equals y squared minus 2t, this is once again a first order ordinary differential equation, but it is nonlinear. This is because it's y squared. I could also have y double prime equals y squared, and this is a second order nonlinear ODE. Finally, I could have a second order linear, or a third order linear, let's say, y triple prime times y plus t squared times y equals cosine of t. And this is still linear because the degree of y is still 1. It is third order because the order of the largest derivative is 3, and it's linear because the degree of y is 1. And you'll also note that the degree of t, which is 2, doesn't matter. Last but not least, there is something called the normal form. This is just the normal way to write a differential equation such that the highest derivative is on the left side of the equal sign, and everything else is a function on the right side, a function of y to the n minus 1th derivative and y to the n minus 2's derivative, all the way down to y and t. That is my independent variable and a function of all the other derivatives in the original function equal to the highest derivative. And that's a normal form. As a quick example, let's look at t plus y times y prime times 4 equals 8. Remember, we want to have y prime because it's our highest ordered derivative on the left side. So we'll say that y times y prime times 4 equals 8 minus t. And from there, we get y prime equals 8 minus t over 4y. And this is the normal form of this. That wraps up a brief intro to differential equations. In the next video, we'll start looking at how to solve some simple ones. I'll see you there.